Hello everyone, welcome to this video on AWS autoscaling. In this video, we will explore how AWS autoscaling can help you manage your infrastructure efficiently, ensuring both cost effectiveness and reliability for your applications. Let's dive in. So, what exactly is AWS autoscaling? Simply put, it's a service that automatically adjusts the number of resources you need based on the demand. It helps you ensure that your application performs optimally without manually managing infrastructure. With AWS autoscaling, you benefit in a few key ways. Cost optimization. You only pay for what you use, scaling your resources based on demand. Availability. Autoscaling ensures your application can handle traffic spikes and keeps it running smoothly. Elasticity. You can scale your infrastructure up or down depending on how much traffic or load your application is receiving. Now, let's look at the core concepts of AWS autoscaling. There are two main types of scaling: vertical scaling and horizontal scaling. Vertical scaling, which involves increasing or decreasing the size of your individual instances, such as upgrading your EC2 instances to a large type. Horizontal scaling, which involves adding or removing instances from your fleet to meet demand. In addition, autoscaling is driven by autoscaling policies, which specify when and how scaling should occur, and health checks that monitor the health of your instances to automatically replace unhealthy ones. Scaling cooldown is another concept that ensures AWS doesn't perform too many scaling actions too quickly, allowing your infrastructure to stabilize between scaling events. Let's go over the main components of AWS autoscaling. Autoscaling groups. In short, ASG. These are groups of instances that automatically adjust based on your scaling policies. For example, you might set a policy to keep between 2 and 10 instances running at all times, and the ASG ensures that's what happens. Launch configurations or launch templates. This defines the instance configurations that will be used when autoscaling launches new instances. This includes things like instance types, security groups, and AMIs. Scaling policies. These define the rules that trigger scaling actions. For instance, a scaling policy might add more instances when CPU utilization exceeds a certain threshold. CloudWatch metrics. Autoscaling uses CloudWatch to monitor your application performance and adjust resources based on metrics like CPU utilization, memory usage, or even custom application metrics. Here is a simplified view of how AWS autoscaling works. You start by creating an autoscaling group with a minimum and maximum number of instances and define the configurations you want for your EC2 instance. Next, you define scaling policies based on CloudWatch metrics such as CPU utilization, request count, etc. These policies will trigger scaling actions. AWS Autoscaling constantly monitors the health of your instances. If an instance becomes unhealthy, it will automatically be replaced to maintain the performance of your application. Based on the policies we have set, autoscaling automatically scales your infrastructure up or down to ensure it can handle the current load. AWS autoscaling can be broken down into two types. First one, EC2 autoscaling. This is for managing your EC2 instances within autoscaling groups. You define the policies and EC2 instances are added or removed based on those policies. Second one, application autoscaling. This is a broader service that can scale resources for other AWS services like Amazon ECS, Lambda, DynamoDB, and more. Each service has its own type of scaling, allowing you to tailor the scaling experience to your specific application requirements. Now, let's dive deeper into the scaling policies that control how autoscaling behaves. Target tracking scaling policy. This is the simplest and most common method. You set a target value for a metric, like keeping CPU utilization at 50%. Autoscaling will adjust resources to maintain that target automatically. Second one, step scaling policy. This policy lets you scale based on different thresholds. For example, if CPU exceeds 70%, you can add two instances, and if CPU exceeds 80%, you add four more. Next one is simple scaling policy. This policy triggers an action when a single threshold is reached. For example, if CPU utilization goes over 80%, it adds an instance, but there is no complex logic involved like in step scaling. Health checks are a critical part of autoscaling. AWS autoscaling constantly monitors the health of your instances. If an instance becomes unhealthy, autoscaling will terminate the instance and replace it with a new one, and ensuring your application remains highly available. There are two types of health checks: EC2 health check and ELB health check. EC2 health check checks the health of the EC2 instance itself. ELB health check checks the health of the instance based on whether it's responding to traffic through a load balancer. CloudWatch plays a crucial role in AWS autoscaling. It collects metrics like CPU utilization, network traffic, and disk input-output, which autoscaling uses to make decisions about scaling. You can also set custom metrics based on your application's needs. For example, if you're running a web application, you might monitor HTTP request count or response time as a trigger for scaling options. Here is a quick comparison of AWS autoscaling versus manual scaling. With AWS autoscaling, scaling is automatic and based on real-time demand. This minimizes cost and ensures performance without manual intervention. On the other hand, manual scaling requires you to monitor and scale your resources manually, which can lead to either over-provisioning or under-provisioning, resulting in higher cost or degraded performance. Now, open VPC, click on Create VPC, VPC only. Next, create an internet gateway and click on Actions, attach to your VPC. Next, we need to create two subnets. Click on Create Subnet, select your VPC. Now, to give the resources in our public subnets access to the internet, we need to set up routes. So click on route table, create route, and ASG route table one, select the VPC, and that's it. Click on create and go to subnet association, edit subnet, click all, there, and go to routes, edit routes, add route, there, and internet gateway, select the internet gateway, that's it, save. Okay, this route tells AWS to send internet-bound traffic via internet gateway. Now we need to create target group. Now go to EC2, click on target group. A target group is like a registry that keeps track of our EC2 instances for the load balancer to forward traffic. Click on create target. Choose a target type instances, and target name will be Successfully created a target group. Now, now we need to create load balancer. A load balancer helps distribute incoming traffic evenly across all EC2 instances. So click on create load balancer. I'm going to create application load balancer. Now let's create the launch template. Click on launch templates. The launch template defines the configuration for the EC2 instances. Click on create launch template. Now let's create the auto scaling group. I'm going to select the launch template which I have created. Select the VPC and select both our empty zones. Click on next. Click on attach an existing load balancer because we have created earlier. And desired capacity will be 2, minimum capacity 1, and maximum desired capacity will be 3. And this configuration ensures there's always at least one instance running with the room to scale up to 3 instances. Next. Now auto-scaling groups has been created successfully. 2 instances are running, it's showing. Desired capacity 2. Now let's check in the instances, refresh it. You can see here 2 instances are running. Now you can see here if I terminate one instance, it will automatically initiate new one. Let's wait for it. See here, one EC2 instance is running. So I'm going to terminate this because you can see here minimum instance should be 1. So that's why it's running one EC2 instance. It automatically initiated one more EC2 instances. And there you have it, a fully functional EC2 auto-scaling setup. With this, your application can handle traffic spikes and maintain reliability without manual intervention. Thank you.